Chapter Review 1, Problem 16. In the binomial expansion of this to the n, the sixth term contains x to the 25. Solve for n. Okay, so let's see, guys. We don't know what this number is, this exponent. We don't know that. Let's write the binomial. 2 over x to the square plus minus 5x to the 5 to the n. Okay, perfect. And we know that the sixth term contains this variable part, x to the 25. So let's see. Let's do something. Let's write the first term, the second term, the third term, and we're gonna jump to the sixth term of this expansion. Even though you don't know this exponent, you can just write it in terms of the formula, right? For example, the first term is going to be equal to n choose 0 times my first number in the binomial to the n. We don't know yet what n is, but that's the formula, right? And times minus x to the fifth to the 0. Okay, this is the first term, guys. The second term is going to be n choose 1 times 2 over x squared to the n minus 1 times minus 5x to the 5 to the 1. The third term is going to be n choose 2 times this n minus 2. As we know, the exponent in the first number is decreasing, right, by 1, n minus 1, n minus 2, etc. And the exponent in the second number in the binomial is increasing. So we should have this. Okay, so by now you should see the pattern. You see, n choose 0, n choose 1, n choose 2. What should be here? Right here, it should be 5, right? Because if you notice, this number is always less, it's always 1 less than the number of term. Can you see? It's pretty simple to spot the pattern. And we can also do some pattern recognition in these exponents. So if you notice, we have second term, and here we have minus 1, third term, and we have minus 2. So sixth term, and this should be n to the n minus 5 as exponent. And same here, we have first term, and we have 0, second term, we have a 1, third, we have a 2, sixth, and we should have a 5. So this is how we should write the sixth term of the expansion of this binomial. This is it. And they tell me that the sixth term contains this variable part, x to the 25. X to the 25. Okay, so that's all I need to know, guys, in order to solve for n. Why? Because once again, forget a little bit about the coefficients, all the numerical coefficients, and just consider the variable part. The variable part of this is going to be 1 over x squared raised to the n minus 5, and the variable part of this, as we can see, is x to the 5 to the 5. And the variable part in here should be equal to x to the 25. Okay, so the rest is quite easy. Let's solve for n. Solve for n. X to the 5 to the 5, that's going to be x to the 25, which is the same as this one. So we divide both sides over x to the 25, and we should get that this raised to this exponent is equal to 1. And there is no other way for a number raised to an exponent to be equal to 1 than the exponent being 0. That's the only way. Any number raised to some exponent can only be 1 if this exponent is 0. Because x to the 0 is 1, and we know that, right? So this exponent should be 0 because this fraction to the 0 will be equal to 1. So n minus 5 should be 0, and so n should be equal to 5, period.